Good day, everybody. Welcome to Maths with Gaston question for November 2022. It was a function question. Let's have a look at part 2. Part 1, it was a hyperbola. So now what we have here is a parabola and exponential function. All right. We have got 4.2.1 up until 4.2.5. So we are going to do them step by step and also try to solve each question as we go. Now let's first analyze this one, and we have given a parabola there at x squared minus 4x minus 5, and then we are given an exponent there, and then also in terms of there's a 2 there, 2 to the power of x plus q. So we need to find them. Then they also go ahead and tell us that E and H are x-intercept of a parabola, and therefore C is also a y-intercept of that lies as a line of asymptotes for the exponent function rather. Okay, we know that's fine. And then two graphs intersect at D. Okay, if we have a look at it, D there, it's also the turning point of a parabola as well. Very, very critical to take note. All right, so let's go ahead and deal with these questions as they come. All right, great stuff. Okay, now 4.2.1 said write down the y coordinate of C. Y coordinate of C. Okay, great stuff. So they want us to write down the y coordinate of C. Y coordinate of C. Okay, where is C? The C is y intercept. Now let's come here to the graph and have a look. There is C there. C is a y-intercept for what? For F. Okay. C is a y-intercept. So we need to come to the graph there, which is the f of x. Now let's come here. Solve this. F of x is equal to x squared minus 4x minus 5. Okay. Minus 5. There you go. So now we're saying is the y-intercept. Y-intercept, we achieve it based on our functions there. We achieve it when x is equal to 0. So therefore, x is equal to 0 in this case. So let's see what is going to be our y. Minus 5. Therefore, when x is equal to 0, y is equal to minus 5. Okay. When x is equal to 0, y is equal to minus 5. Therefore, the coordinate at C is going to be 0 is to negative 5, which is good. Great. So it makes sense now. We got it. So we have got this coordinate here, 0 is to 5. Sorry, negative 5 rather. Close bracket. Therefore, they said determine the coordinates of D. D, there it is D there. What is D in terms of the terms is the turning point of the parabola, which is this one, the f of x. Okay, so let's come here. 4.2.2. What is the function there? You must know based on our discussions and previous videos that we only get the turning point when the first derivative is equal to 0. Okay, so let's take the first derivative here. Accordingly, the first derivative should be equal to 0. So 2 comes down, then you minus 1 from the top, minus this is to the power of 1. 1 comes down, you're going to have 4, and therefore x to the power of 0, anything to the power of 0 is equal to 1. Okay, and the derivative of a constant is 0. So therefore this should be equal to 0. Therefore you're going to solve for x, 2x, then you take 4 to the other side of the equal sign is going to be equal to 4. Therefore divided by 2, divided by 2. Therefore our x is equal to 2. All right, so the question asks us to find the coordinates. Therefore we are gonna come here and say, let me rather write it here, come here and say, what is the y value when x is equal to 2? 2 squared minus 4, 2 minus 5. So therefore, when you punch this our calculator, our y value is going to be minus 9. Okay. So very, very critical, guys, on knowing what to do here. So therefore, the coordinates of D would be equals to 2 is to minus 9. Okay, and that's how you would deal with a question like this one, where you have to solve and also use the turning point. But on the turning point, please take note, NB, on the turning point, this question here, you could also use x is equals to minus b over 2a. All right, where b is this one here, and then a is one that is sitting here. Okay, so you could use this to solve this, and then once you get the x value, you could substitute it back to the original equation here and also get the y value as well. So please guys, double check the turning point using this method here. I only show one method where you are using the derivative to find the turning point. All right, so now let's go ahead and do the other questions that follow after this one. Okay, now we are looking at 4.2.3. So it says write down the values of A and Q. Values of A and Q. Values of A and Q in this question, they are there on G of X. G of X is equals to A times 2 to the exponent X plus Q there. All right, great stuff. So now, in order for us to be able to do this, we need to check on our graphs here the line of asymptotes. Okay, so we already know the coordinates here is 0 is to negative 5 as calculated previously. Then our turning point here, it's 2 is to minus 9. Interesting, yeah? Okay, great stuff. So now, what do you do here in this case? So what you do here, already you can see that this line here is given by y is equal to minus 5. Okay, so now is the line of asymptote of the g, which is the g here. That's our graph there. So therefore, if that's the case, therefore q should be equal to negative 5. Okay, because it's the line of asymptote of a exponent graph. So therefore q should be equal to negative 5 as given by the coordinates of c. Okay, this is given by this coordinates here of c, is this dotted line here, guys. Please pay attention, is this dotted line here. All right, so once we have that, we can come here and substitute it in our original equation here and said a 2 to the power of x minus 5. Okay, do we have any coordinate that is on the graph of G that we can use so that we are able to find A? Yes, there is. Ladies and gentlemen, there is D. Okay, so we can use D now. So we can say, okay, if we're using D, what is y? Y is minus 9. A, we're looking for it. 2 to the power of x. X is what? Is 2 minus 5. Okay, so therefore you can take 5 to that side. Minus 9 plus 5 is equal to a 4, because 2 to the power of 2 is equal to 4. Therefore we can divide by 4 all the sides here. Divide by 4, therefore is going to give us a is equal to, a will be equal to minus 4 divided by 4 is going to give you minus 1. All right, great stuff. Great stuff. All right, and that's how you will deal with this one. Q, you get a mark for Q, and then you would also get your mark for that, and you'll also get a mark for working out the value of A. All right, great stuff. So therefore, now we need to come to 4.2.4. It says write down the range of G. So G is an exponential graph. So we know that from the line of asymptotes, this graph will go there as far as possible. So it is safe to say it's gonna go to as far as what? As long as this is what? This is the x value, no, yeah, this is the x value. So it will go to negative infinity on the x value because it's going non-stop. But on the y value is it needs to be greater than 5. Sorry, greater than let me see. Okay, yeah, the value needs to be less than minus 5. Is it? Let me just check. Yeah, the value needs to be great. Yeah, needs to be Yeah, needs to be less than -5 going down. All right. So therefore, what you can do, range, they're asking you for the y values. Okay. So there's no need for you to worry about the x range. You can say range, it will start from negative infinity and then negative -5 as a line of asymptotes. So it's not supposed to touch -5 because it is the line of asymptotes. Okay. And therefore you should be able to get a mark there. Guys, if let's say for an example, such things you get a bit confused. I mean, it's just 1 mark. You can skip it and then you will come back to it if you really don't understand it. Okay. Because I know some teachers prefer using inequalities and what, and it just gets a little bit confusing for most of the learners in that regards. Okay, right. So now let's have a look at 4.2.5. 4.2.5 is saying determine the value of k for which the value of f of x minus k will always be positive. Okay, the value of this will always be positive. Okay, all right. So now anything that is from the turning point going upwards, this is the positive gradient. Okay, these questions they like normally asking them for, they like to ask them on cubic functions. Okay, so but I see now they brought it here on hyperbola. So this graph will only be positive if k is less than, sorry, if k is less than -9. Okay, but let's see this. If k is less than -9, there is -9 there, there is -9. If k is less than -9, can you see? So if k is less than -9, what is happening there? When it's less than, when it's greater than, this graph starts moving this side. But when it's less than, it starts moving going that side in a positive direction. So therefore, that's how you would deal with 4.2.5. And ladies and gentlemen, that's how you would deal with question 4. If you've got any questions or you've got any comment or we made a mistake while we're busy trying to solve this question, please make sure that you leave your comment on the comment section below. We will definitely do the correction for that question and assist you where we can. Would you, if you want a one-on-one, make sure that you drop us a WhatsApp. We will be able to assist you where we can. I am Gastin Mapala. See you on the next upload where we will be dealing with question 4, 2001, November.